Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about liquefaction of gases and critical temperature. Liquefaction, you know, the liquefaction of a gas takes place when the intermolecular forces of attraction become so high that they bind the gas molecules together to form the liquid state. The intermolecular forces of attraction can be increased either by increasing the pressure so that the molecule come close together or by cooling the gas so that the kinetic energy of the molecules decreases and they become slower. You also know that the effect of temperature on liquefaction of gases is found to be very important as higher the temperature of the gas. More difficult it is to liquefy it and higher is the pressure required. Gas like hydrogen, helium, oxygen, nitrogen could not be liquefied at room temperature by application of pressure alone. Each of these gases could also be liquefied provided first it is cooled down to or below the particular temperature. For each gas, there is a particular temperature above which it cannot be liquefied. Howsoever, high pressure may be applied on the gas. This temperature is called critical temperature. My friend, critical temperature of gas may be defined as the temperature above which it cannot be liquefied. However, high pressure may be applied on the gas. The pressure required to liquefy the gas at the critical temperature is called critical pressure. The volume occupied by 1 mole of the gas at critical temperature and critical pressure is called critical volume. All the three are called critical constants of the gas and are represented by Tc, Tp and Tv. Look at this picture and do experiment on critical phenomenon. This is the critical pressure. Volume at this point is critical volume and temperature on this point is critical temperature. Andrews in 1861 was the first to study the critical phenomenon experimentally using carbon dioxide. He studied the effect of pressure on the volume of carbon dioxide at different constant temperature. The plots obtained are called isotherms. At the lowest temperature implied, that is 13.1 degrees Celsius, at low pressure, carbon dioxide exists as a gas, as shown at the point A. Look at here. As the pressure is increased, the volume of gas decreases along the curve. The point at which liquefaction of gas starts, volume decreases rapidly because liquid has much less volume than the gas. Once the liquefaction is complete, the increase in pressure has very little effect upon volume because Liquids are very little compressible. You know that. Hence, a step curve is often steep curve. As the temperature is increased, horizontal portion becomes smaller and smaller, and at 13.98 degrees Celsius, it is reduced to a point E. Look at here. So above 13.98 degrees, the gas cannot be liquefied at all. However, high pressure may be applied. Thus, 13.98 degrees Celsius is the critical temperature. We get a dome-shaped curve. You can see this is a dome-shaped curve. A point like A represents gaseous state. A point like D represents liquid state. Look at here, D. A point within the dome-shaped area represents existence of liquid and gaseous carbon dioxide in equilibrium. This dome-like structure here, liquid and gases are in equilibrium. So, importance of critical temperature. A critical temperature of gas is a measure of the strength of the intermolecular force of attraction. Weaker are the intermolecular forces, more difficult is to liquefy that gas, and hence lower would be the critical temperature of the gas. Helium and hydrogen have weak intermolecular forces, thus they are difficult to liquefy and hence have low critical temperature. Carbon dioxide and ammonia have a strong intermolecular force of attraction. They can be easily liquefied and their critical temperature are high, which are above room temperature. You know, van der Waals constant is also a measure of intermolecular force of attractions. Hence, it is found that the values of constant increase in the same order as the critical temperature. As a gas can be liquefied below the critical temperature by applying pressure, therefore, above the critical temperature, it is a gas, but below the critical temperature, it is a vapor. So, friends, for example, carbon dioxide below its critical temperature is called carbon dioxide vapor. So, my friends, I hope this video will be helpful to you. If you like such type of or this type of video, then subscribe my channel and thanks for watching.